It is the most extreme planet in the solar system. Some call it Earth's twin sister. Others refer to it as the hell of the solar system. Viewed from Earth, it is the brightest star in the night sky. Beautiful and captivating, but upon closer inspection, it possesses the harshest environment in the solar system. Hotter than Mercury, more desolate than Mars. This is our neighbor Venus. Hello everyone, this is the second episode in the series on the 8 planets of the solar system. In the time that follows, let us explore Venus together. It's little known. Extreme world. It is the second planet from the Sun among the 8 major planets, and also the closest planet to Earth. When viewed from Earth, Venus is the second brightest celestial body in the night sky, second only to the Moon. Its size, mass, and volume are all similar to Earth's, so it is often called Earth's sister planet. Venus has a diameter of about 12,092 kilometers, only 650 kilometers less than Earth's. Its mass is 81.5% of Earth's. Its volume is 86.6% of Earth's. Its gravitational acceleration is 90.4% of Earth's. Venus orbits the Sun at an average distance of 108 million kilometers. It revolves around the Sun, with one orbit taking about 224.65 Earth days. Interestingly, if you were to look down on the solar system from above the Sun's North Pole, you would see that all the planets orbit in a counterclockwise direction. The rotation of most planets is also counterclockwise, known as prograde rotation. But Venus's rotation is clockwise, unlike all other planets. This means that if you were to stand on Venus, you would see the sun rise in the west and set in the east. On Venus, you could truly say that the sun rises in the west. Furthermore, Venus's rotation period is the longest among the 8 planets. Its rotation period is about 243 Earth days, which is longer than its orbital period. The phrase, "a day feels like a year," is perfectly embodied by Venus. If you observe Venus up close, you will find that this planet, known as Earth's sister, is vastly different from Earth. Venus has the thickest atmosphere among the 4 terrestrial planets, with 93 times the mass of Earth's atmosphere. The atmospheric pressure on Venus is extremely high, 92 times that of Earth's. This is equivalent to the pressure at a depth of 1 kilometer in Earth's oceans. The atmosphere of Venus is composed of 96% carbon dioxide. This unique atmosphere creates the most powerful greenhouse effect in the solar system. This results in Venus's surface having an average temperature of 464 degrees Celsius, with extreme temperatures reaching 500 degrees Celsius, making it the hottest planet in the solar system. It is even hotter than Mercury, the planet closest to the Sun. Furthermore, the heat on Venus's surface shows no variation with region, season, or day and night. In simple terms, it's hot everywhere. According to research, between 2 to 3 billion years ago, Venus's atmosphere was very similar to Earth's present-day atmosphere, and it may have had abundant liquid water on its surface. Later, due to a runaway greenhouse effect, the original water evaporated, causing the concentration of greenhouse gases in the atmosphere to exceed a critical level. Above Venus's atmosphere, there's a thick cloud layer, 20 to 30 kilometers thick, composed of sulfur dioxide and concentrated sulfuric acid. This means that Venus experiences corrosive acid rain. But there's no need to worry. Due to the extremely high surface temperature of Venus, raindrops evaporate completely before reaching the ground. The high surface temperature is also related to this thick cloud layer. The carbon dioxide in dense clouds allow sunlight to pass through, but prevent heat from escaping through the clouds into space. This heat is essentially trapped between the cloud layer and the surface of Venus, causing the surface to become progressively hotter. Simultaneously, these clouds completely cover the entire surface of Venus, making it difficult for observers on Earth to see through this thick veil. To observe Venus, Most of Venus's surface consists of plains, formed by recently solidified lava flows. No speech. Above these plains, there are two major continental-sized highlands. The northern highland is called Ishtar Terra, about the size of Australia. It contains Venus's highest mountain range, Maxwell Montes, which is about 2 kilometers higher than the Himalayas. The southern highland is called Aphrodite Terra. It is the largest continent-like highland on Venus, with a size comparable to the continent of Africa. The surface of Venus is covered with volcanoes, several times more than on Earth. Over 1,600 major volcanoes and volcanic features have been discovered. In addition, there are countless smaller volcanoes. No one has counted their exact number, but the total is estimated to exceed 100,000. Venusian volcanoes have various forms. Besides the common shield volcanoes, there are many complex volcanic features and intricate volcanic structures. Venus's surface also has a unique terrain called arachnoid terrain. As the name suggests, its appearance is like a spider web. This type of terrain has only been found on Venus, and to this day, scientists have not been able to determine its formation process. Beginning in the 1960s, the United States and the Soviet Union raced to send probes to Venus, attempting to unveil the secrets of this mysterious planet. Venera 1, launched on February 12, 1961, was the first probe to fly towards Venus. After entering a solar orbit, communication was lost, yielding no detection results. The United States Mariner 2 probe, launched on August 27, 1962, on December 14th of the same year, flew past Venus at a distance of 3,500 kilometers. It was the first to measure Venus's atmospheric temperature and captured images of the planet. It was the first successful probe to explore Venus. The first attempt to land a probe on the surface of Venus was the Soviet Union's Venera 4 probe, launched on June 12, 1967. No speech. It entered Venus's atmosphere on October 18th of the same year. The main spacecraft successfully released the lander, which began its descent and started transmitting signals. When the lander descended to approximately 24.96 kilometers above the surface of Venus, the signal transmission ceased. It is presumed that the lander was damaged by Venus's high atmospheric pressure. Venera 4 provided us with the first analysis of the chemical composition of Venus's atmosphere. It revealed that the main component is carbon dioxide, with only a very small amount of nitrogen and less than 1% oxygen and water vapor. These data greatly enhanced humanity's understanding of Venus's environment. The first probe to achieve a soft landing on Venus was the Soviet Union's Venera 7, launched in August 1970. On December 15, 1970, the Venera 7 lander separated from its orbiter, traversed Venus's dense atmosphere, and successfully landed on the surface of Venus, becoming the first probe to soft land on another planet. No speech. Although Venera 7 only operated for about 23 minutes after landing, all the data it transmitted provided scientists with valuable first-hand information, giving people a deeper understanding of Venus's extreme and complex climate features. No speech. Subsequently, the Soviet Union continued to send probes to Venus. Among them, the Venera 9 probe captured and transmitted humanity's first image of the Venusian surface. It also transmitted data on the thickness of Venus's clouds and their composition, and conducted dozens of scientific experiments. The Venera 13 probe set a record for operating on the surface of Venus for 127 minutes. By the time Venera 13's signal was finally lost, it had transmitted 8 stitched color panoramic images, 26 minutes of wind sound recordings, 11 sets of rock sample data, and 32 atmospheric parameters. What you are seeing now is real footage from Venus. Later, Venera 15 and 16 completed continuous orbital mapping of the Venusian surface using radar, accumulating more comprehensive planetary data. By 1990, NASA's Magellan probe arrived in Venus's orbit. It was equipped with an advanced synthetic aperture radar system. This system transmitted microwave signals that penetrated the perpetually dense clouds of Venus, successfully capturing information on the surface topography and details. This opened up a completely new perspective for exploring Venus. Over the next 4 years, the Magellan probe precisely orbited Venus. Through high-precision scanning, it ultimately achieved a resolution of 120 meters, completing the mapping of 98% of Venus's surface area, creating an unprecedentedly detailed map. In addition to the aforementioned Soviet and American missions, the European Space Agency, ESA, also developed this was Venus Express mission to Venus. The reason it's called Venus Express is not because it traveled fast, but because it was developed quickly. The Venus Express project was proposed in 2001. From the initial concept proposal to the probe being ready for launch, it took only 4 years in total. The Venus Express probe was the first to completely document the phenomenon of superrotation in Venus's atmosphere and created a global map of atmospheric circulation. Through infrared thermal imaging, it discovered that Venus may still have active volcanoes, significantly changing our overall understanding of the geological state. In the future, NASA plans to launch 2 more Venus probes by 2031. Their missions will help us answer the biggest mysteries about Venus. Why did this planet, so similar to Earth, evolve into the hellish world it is today? Actually, during the exploration of Venus, the most interesting aspect is about whether life exists on Venus. As early as 2020, an international research team, through the study of Venus's atmosphere, detected a faint signal of phosphine for the first time. Phosphine is a colorless, highly toxic flammable gas with a strong, irritating odor. In nature, phosphine is a toxic gas produced by decaying organic or bacterial activity. It is almost always closely associated with life's activities in other known non-biological processes. The probability of forming phosphine is extremely low. On rocky planets, this gas can only be produced by biological activity, and this gas has become one of the important markers in the search for potential extraterrestrial life. So, how did the phosphine on Venus come to be? Scientists have proposed various hypotheses to explain this phenomenon. One theory suggests that Venus's clouds may harbor some unknown microbial communities whose life forms are completely different from life on Earth. No speech, able to survive in extreme environments and produce phosphine. Another viewpoint is that phosphine may originate from complex chemical reactions between the surface and atmosphere of Venus. This hypothesis has the highest probability. However, this explanation still requires more experimental evidence for support. As we gaze at that brightest star in the night sky, it's perhaps hard to imagine its hellish true face. As we continue to send probes to Venus, perhaps the most important question to consider is, will Earth follow in Venus's footsteps? I hope this episode has given you a better understanding of Venus. Thank you for listening. I trust you're still awake. I am the Space Lens. May the vast cosmos accompany you throughout your life. See you next time. Thank you for watching the Space Lens, exploring the mysteries of the universe. If you enjoyed this video, don't forget to like and subscribe to join us on the next journey through space.